Colpitt oscillator. It is a transistor LC oscillator where the tank circuit consists of inductor L is connected in parallel to serial combination of capacitors C1 and C2. This RF choke is used to give easy path for DC and obstruct AC signals. When the circuit is turned on, the capacitors C1 and C2 are charged. The capacitors discharge through L and setting up oscillation of frequency F is equal to 1 by 2 pi root LC, where C is C1 C2 by C1 plus C2. The output voltage is the voltage across C1 and the feedback voltage is voltage across C2. The voltage across C1 and C2 have a phase shift of 180 degree. The voltage fed back to the transistor provides a positive feedback. A phase shift of 180 degree is provided by C1 C2 voltage divider, and a further phase shift of 180 degree is provided by a transistor. In this way, feedback is properly phased to produce continuous undamped oscillations. Thus, the feedback factor beta is equal to Vf by Vo, where Vo is the voltage developed across C1 and Vf is the voltage developed across C2. Thus, beta is equal to C1 by C2. Colpitt oscillators are used in high frequency sine wave generators, local oscillator in radio receivers, RF oscillator, and in mobile applications, surface acoustical wave resonators, and in sensors. Hartley oscillator. It is a transistor LC oscillator where the tank circuit has a capacitor connected in parallel to serially connected inductors. When the circuit is turned on, the capacitor is charged. When this capacitor is fully charged, it discharges through L1 and L2 that set up an oscillation of frequency F is equal to 1 by 2 pi LC, where L is equal to L1 plus L2 plus 2M. M is the mutual inductance between L1 and L2. Here the output voltage across L1 and feedback across L2. This connection gives a phase shift of 180 degree. The voltage feedback to the transistor provides positive feedback. Thus, a phase shift of 180 degree by L1 and L2 and a further phase shift of 180 degree is provided by transistor. Thus, feedback is properly phased to produce continuous and damped oscillations. Feedback factor beta is equal to Vf by Vo, where Vo is the voltage across L1 and Vf is voltage developed across L2. Thus, beta is equal to L2 by L1. Hartley oscillator is used to produce sine wave of desired frequency, as local oscillator in radio receivers, and as RF oscillator. Phase shift oscillator. A phase shift oscillator produces sine wave using RC phase shift network. In LC tank circuits, they suffer from frequency instability and pure waveform, and they cannot be used for very low frequencies because they become too much bulky and expensive. In phase shift oscillator, it uses an RC phase shift network to produce oscillations and sufficient phase difference. In this phase shift oscillator, it uses 3 RC network. Suppose E0 is the input voltage and E0 prime is the voltage developed across the resistor R. We know that the alternating voltage E0 prime across R leads the applied voltage E0 by 5 degree. The value of phi, phase shift phi, depends on R and C. In this circuit, each RC network provides a phase shift of 60 degree, so that a total phase shift of 180 degree. When the circuit is switched on, it produces oscillation of frequency F is equal to 1 by 2 pi RC into root 6. Thus, this network provides a 180 degree phase shift and the transistor provides 180 degree phase shift, so that a 360 degree of phase shift and makes continuous undamped oscillation. And its feedback fraction is EI by E0. Phase shift oscillator does not require transformer or inductors. It can be used to produce very low frequencies. The circuit provides good frequency stability. But starting the oscillation is difficult as the feedback is generally small. The circuit gives small output.